Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology. So in today's class we are going to have the topic recurrence relation. So first we should know what is meant by a recurrence relation. So we can write an be a sequence of real numbers as an as the nth term and the recurrence relation of the sequence, so which is an equation that expresses in terms of one or more earlier terms. So based on the earlier terms, we are going to define the new terms, so which is called recurrence relation. So one of the example is Fibonacci sequence, which is 0, 1. So if we are having 0 and 1, we can write the remaining numbers series. Okay. And which is represented in the form of fn equal to fn minus 1 plus fn minus 2. N is greater than or equal to 2. Okay, with the condition f not equal to 0 and f1 equal to 1. Now we are going to have homogeneous and non-homogeneous. So first we will see what is meant by a homogeneous recurrence relation. So homogeneous is nothing but in the right side if you have 0 then we can say which is homogeneous. Okay, for homogeneous we will have the solution which is of the form yn equal to hs plus ps. Okay, then how to find the value of hs? Yes, so first we need to write the characteristic equation and solve and find the roots. Okay, based on the roots just you find the solution. Okay, and there are three cases. Okay, and the next thing is we are going to find the particular solution. So for particular solution we are having a few cases. Okay, I have to check the right side term. If the right side term is k, that means the constant term. Okay, if it is a constant we can have the term as a, just a constant. Okay, it may be a or d, something like that. Okay, and the second thing is if it is a k power n, that k is a constant, so I have to check whether that k is a root or double root or it is not a root. Based on that I have to choose the particular solution. Okay, we need to select the term. Okay, and the next thing is f of n is a polynomial. If it is a polynomial, I have to take the form in this form. You can see it, right? And if you are having the fourth case, that is k power n into some polynomial, so we can write the term as like this. Okay, so the first thing is we are going to find the order. For that, highest minus lowest subscript, you can check it in the given problem. Okay, you can have the highest as n and lowest as n minus 2. If you subtract these two, the order is 2. Okay, here we are having two types of problems. The first thing is sequence is given, we need to find the relation. The second thing is the relation is given, we need to find the solution. Okay, we will see one by one. Okay, now the first problem is just they are given the sequence and we need to find the recurrence relation. Okay, and what are the things we need to do? Yes, based on the previous term only we need to define the relation. So that means we need to take a n minus 1, just you would put n as n minus 1. So 3 into 2 power n minus 1. So which is 2 power n by 2. Okay, so from this we can find the relation which is a n equal to 2 into 2 times of a n minus 1. n is greater than or equal to 1. Okay, and a naught is what? Yes, just replace n as 0. So finally we are getting a naught as 3. So this is one type of problem. If you see in the problem, okay, yes, the next thing is we are going to have the relation s of n equal to 6 times of minus 5 the whole power n. Now replace n as n minus 1 on both sides. Okay, we'll get some relation which is s of n equal to minus 5 times of s of n minus 1. n is greater than or equal to 0. Okay, and the next problem is, you can check the problem because in the problem right side there are two constants a and b. So a into 2 power k plus b into 3 power k. Just replace k as k plus 1 in the next step. Okay, and we are getting a into 2 power k into 2 plus b into 3 power k into 3. Okay, and replace k as k plus 2 in the next step. Okay, we are getting three equations. So from these three equations now we are going to have the new determinant. Okay, the left side is yk plus 1, yk plus 2. That is the first column. And the second column is in the right side, you can check the first term. If anything is common, just leave that and take the coefficient of that term. Okay, which is 1, 2, 4. And the third one is just take the common one as b into 3 power k. You can take the coefficient. Okay, which is 1, 3, 9. Now equate the determinant to 0. So from this we are getting the recurrence relation like this. Okay, so this way we need to find the recurrence relation if the sequence is given. Okay, the other way is what? Just we are going to have the recurrence relation, then we need to find the solution. That is one form. This is another form. Okay, so in the similar way we'll have okay, this is one more problem in the similar way. Just find yn plus 1, yn plus 2 and form the determinant and just expand the first row. So we'll get an equation. That equation is called the recurrence relation. Okay, so the remaining concept we will see in the next class. Thank you.